Okay, so let's talk about rational numbers, okay? Now, with classifying rational numbers, there are, the four types of numbers that we talked about in the video, right? We have our natural numbers, we have natural numbers, whole numbers, integers, and rational numbers. So let's start with the very first one. This is the one that you started with back in elementary school. And the first one is natural numbers. Now, if we use the word numbers, I'm okay if you use the abbreviation or, a little symbol like that. But if you want to write it all the way out, you are more than welcome to. I don't mind. These are your notes. Yes, I'm picky about you writing everything down, but if you need a shorthand, that's okay, right? I wouldn't have survived middle school, high school if I didn't have my shorthand techniques. So you can definitely do that if you need to. So it's about rational numbers. You can think about rational numbers as counting numbers. And you can also think about it as the ones on your fingers. Now, what does that mean, counting numbers on your fingers? That means it's my numbers from 1 and onwards. I'll give you all a minute to write that. So natural numbers are our counting numbers, the ones on our fingers, that we count from 1 and onwards. So for example, if I start at the number 1, right, I can count that on my fingers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I can keep going on and on my fingers with those numbers. So think about like elementary school, those first few numbers that you started counting, right? Think about those naturally just a part of your fingers, okay? So because it's like that, this is a way we remember it. Now notice it doesn't include 0. We don't include 0 because think about it. Do you ever start on your first finger and say, oh, 0, 1, 2, 3, 4? No. Okay, you don't say you have 4 fingers. Okay, and before y'all start debating me, oh, Mr. Daniel, a thumb's not a finger, okay? Just go with me on this one, okay? In the terms that we think about all of our little extremities as fingers, okay? Quick question, let me see. Musa, what's up? Hold on, Shalok. Musa had his hand up, so let me hear from him first, okay? Musa, you got a question?
So it says on your page that your number is 10, are we 9 or 10?
So on page 9, it's that asynchronous activity I assigned yesterday. So, or on Monday, the one I told you how to do notes for. So that's going to go on page 9. This is page 10. Okay?
I started the thing on page 8, but
Yes.
I didn't have enough room, so I went to the next page, but I did that number 8. So
Right, and that's okay, right? So you have 2 of those page 8s. Then the next page, if you already started, just label it as page 9. Label it as page 10. Just scratch out the 9 and put 10. And then after that, you're going to do page 9. Page 9 is the notes page I asked y'all to do. So that's something we're going to talk about later. Okay? All right, no problem. All right, Shalok, what's up?
So, for you, number 10 is on your left side, right?
Uh-huh.
I mean, on your right side?
Yeah, it's on mine's on my left side. And that's okay. That's okay because everyone's going to have their notebook a little bit differently than me. Okay? So don't worry about it.
It's not like that. They're like, your hole's on the right side, so that means like, I skipped an extra page in the beginning, so that's why my holes are on the left.
Okay, and that's okay. You'll still have, I'm still using one page, right? So like Shalok, I know you joined us from a different class, and that's fine. So don't, if it's that, if the side of the paper, I don't care. It's just the page number and title I'm worried about.
Okay.
All right, let's keep it rolling. The next step in number are our whole numbers. Sorry, I know it went blurry. Okay, our whole numbers. It includes all natural numbers. Okay, so it's still our counting numbers. It's still the same counting numbers that we're using, so it includes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so on. But now we are including 0. Okay. So again, let's look at some of these things. So for example, natural numbers. Let me do some examples. Okay, I'm going to do like 2 or 3 numbers as an example. So some examples, because I forgot to put that in there. Examples of natural numbers include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can count forever. You can go all the way up to 500 if you want. So I could say 1, 2, and I can keep counting on and on. I could also do 52. I can count 52 on my fingers. It might take forever, but I can still count up to 52. I could even count up to 278. I'm going to put these 3 dots because it could go on forever, right? I could spend the entire class period literally counting all my different types of numbers. So that's something you might want to think about, you know, an easy way to memorize it as our natural numbers. Okay. Any questions? We're good. We're live breathing. I don't want to stress y'all out. Okay, trying to take my time. All right. So let's keep it going because I have y'all open and see all your wonderful faces. Thank you for most of y'all for keeping your cameras on. I'm taking note who's not. Okay, so don't waste any time. So let's do integers next. So we talked about integers yesterday. Now it's not integer numbers. Integers are the type of number. So with integers, we defined that yesterday with our stations, hopefully. And remember, I have a copy of my notes in Schoology. So this integer property station, I already have it in Schoology. So if you need to, you can go look at it, take care of it there. So integers are all our whole numbers, but it's the positive and negative version of my whole numbers. So it's all positive and negative whole numbers. Now some things to notice. Okay, you didn't hear me say anything about fractions or decimals, right? You didn't hear me say, oh, counting numbers, I can count 1/4, 2/4, 3/4, 4/4. You don't naturally count that way. Think about it in elementary school. In elementary school, you never started counting, you never counted your fingers as fractions, right? You started with 1, 2, 3, 4, 5, right? Sesame Street numbers, whatever you want to call it. Okay? But those are the kind of numbers that we use, and those are the numbers that we want to classify as counting. Integers are all those same numbers, and including 0, but we do the negative versions also. Okay? So, I forgot to do examples of whole numbers. So some examples of whole numbers. It's still the same numbers, like 1, 2, 52, but now I can include 0 as a whole number. You can include any other counting number. You can even put 75, I'm just with 3 dots, so on and so on, because it has space. If you don't have space to put the example there, you can draw an arrow and put it off to the side. That's fine also. Some examples of integers. So it's all positive and negative whole numbers. So I'm definitely keeping my regular just whole numbers that we counted earlier. So I still have 1, 2, 52, and I can go on forever. But I have negative whole numbers. So I could say -1, -2, -52, and I can just do all of those numbers. Think about it as all whole numbers and their opposites. That's what we defined it as yesterday. The set of all whole numbers and their opposites. So, I could keep going on. I could say 76, -92, and I could just keep going on and on and on. And I put those 3 dots because I could literally fill up this page with a bajillion different types of numbers, right? But I'm just going to leave it at what I have. All right, and the last category we're going to look at is rational numbers. Now, there is another category in the real world of numbers. There's actually two other categories. But we're only going to focus on this last and fourth one. And this last one is, like I said, rational numbers. Rational numbers. Now, if you don't like me doing the little hashtag with the apostrophe S, you don't have to do it that way. Okay, you can definitely write out the word numbers, fine with me. But it's whatever you are going to do to be successful for yourself, okay? Because at some point, it's on you. So just think about it that way. Rational numbers. I want to make sure I word it kind of in a way that you'll understand it.
Mr. Daniel,
Yes, Sherlock, what's up?
could you get us simple water?
Yeah, go ahead. But we're going to keep going, okay? So just keep that in mind. We're going to keep moving, rocking and rolling. Okay. So when we think about rational numbers, it's all of our whole numbers, it's all integers, but now we're including our fractions and decimals as positive and negative numbers too. But there's going to be two ways we're going to write it. The first way, and we're going to talk more about this tomorrow, is any number that can be written as A over B. Okay? So it looks like a fraction, right? A over B looks like a fraction. So that's what we're going to be thinking about it tomorrow. We'll talk more about it tomorrow, but it includes all integers. It includes all whole numbers. It includes all natural numbers, but we also include our fractions. And this is where A and B are integers and B cannot equal 0. So I'll give you all a minute to write that. Rational numbers are any number that can be written as A over B, where A, wherever I plug in for A, and whatever I plug in for B must be an integer. But B cannot equal 0. Now that's going to be a whole other definition we dive into tomorrow. Because if I try to go in depth with that, that'll take a good amount of time. Normally if we had our normal, Monday, Tuesday schedule, I could. But just for our Wednesday schedule, we're going to save that for tomorrow so that we can explore and practice a little bit more. Now, here's the other part. Another way to think about it, okay, I'm going to separate it with the semicolon, you can do that. But another way to think about it is that it's all integers including positive and negative, again that's just an abbreviation way, fractions, decimals, and percents. Now you got to be careful with some of the fractions, because some fractions, when we simplify it, it could be a whole number. So we'll talk about some of those tricky ones tomorrow. But you want to make sure that when we talk about fractions, decimals, percents, for example, if I say 1.00 or 1 and 0 hundredths, that's still a whole number, right? Because it's not really a decimal value there. Okay, so let's explore all these. We're going to start building our Venn diagram. When we build our Venn diagram, you want to make sure you kind of do it with me, okay, not getting lost or confused in between. So let me get my, I'll just keep using this one, that's okay. So let's create our Venn diagram. Now, you can use a good chunk of the bottom space if you'd like. Okay, let's do this. Don't use the whole bottom space. Okay, so I'm going to show you what my paper looks like. So I still have a good chunk of my notebook left. Okay. Now, if I were to do my Venn diagram, don't go all the way to the bottom. I would say skip maybe 6 lines at the bottom. So if you want to draw a line and skip the bottom 6 lines. Now, if you don't have the exact notebook I asked you to get, then that's something different. I don't know how to help you with that. That might be something you got to estimate. But I'd say at least 6 lines you will need for tomorrow's work and discussion. Okay? So don't go overkill on making your Venn diagrams. Okay? So you might want to watch me make mine, but we're going to kind of build that same Venn diagram that we saw in the video. And we're going to, after we build that Venn diagram, then we're going to start placing numbers where we think it would go on the Venn diagram. Okay? So just like the video talked about, natural numbers is the very first type of number that we have. So you can draw and do, this Venn diagram a lot of different ways. Okay? So I'm trying to think how I want to lay it out for y'all so we don't get it mixed up or anything. Let's do... So again, I leave 6 lines at the bottom blank. Okay, so those 6 lines I'm going to leave blank. So I'm going to start here and write the word natural numbers. I'm going to skip a line and write integers. Nope, sorry. Before integers. Sorry. For integers, we have our whole numbers. Let's skip a line. Then we have our integers. And lastly, we have our rational numbers. Okay, so for my Venn diagram, and again, you can watch me before you make it and kind of adjust the coordinate, but we're going to do the same one that I did in the video. So over here we have our rational numbers. So with natural numbers, in our next circle is going to be whole numbers, but make sure when you make that circle for whole numbers, you include your natural numbers. So if I put a number inside this box, it would apply to whole numbers and natural numbers. And then we're going to do another box outside the word integers. See, I could have moved this up a little bit, but it's okay. We'll move on. And our last one is rational numbers. Okay. So again, it's okay, guys, if it's not perfection. Okay, not a big deal. As long as you can read it, I'm happy. Okay, so don't worry if it looks sloppy or anything like that. It's totally fine. Now, anytime we start classifying these rational numbers or any type of number, we always start in the middle of this Venn diagram, or the smallest circle possible. So from there, we start going out, and then we start classifying. So let's look at the numbers that we kind of wrote down, and we're going to talk about a few other examples. Okay? Let me hear from, using these definitions, okay? We're going to try to think about different words or different numbers and their different classifications. Okay? Let me hear from Dean. Dean, go ahead and unmute your mic. Tell me, what is an example? Give me one random example of a natural number.
760.
Okay, that's fine. A little extra, that's okay. 760, you said?
Yeah.
Okay, cool. All right. Tell me, Anaya, go ahead and tell me what another example of a natural number. Nope, I don't think Anaya's here. Nope, that's my old list. Okay. Give me another example. Shara, go ahead and give me another example. Okay, 370, and I can go on forever, right? I can say 1, I could say 2, I could say 14. Okay, I'm going to put those 3 dots, ellipses if you want, and keep going on and on. Now guys, notice, if there's a number inside of here, it's also inside whole numbers, it's also inside integers, it's also inside rational numbers. Just think about the Venn diagram we talked about earlier. When you were in the middle, you are a student at Fort Bend ISD. You are a student in the state of Texas. Am I missing one? No, sorry. Rewind. You are a student at Garcia Middle School. You are a student in Fort Bend ISD, and you are a student in Texas. So those are the things you have to remember, right? If you're having a hard time thinking about, oh, how do I classify this number, right? Think about that example. So when I say, hey, what is 760? You can say it's a natural number. You could also say it's a whole number. You could also say it's an integer. And you could also say it's a rational number. Okay. So let's think about whole numbers. My definition is counting numbers including 0. So I can put 0 over here. But I can't put 0 inside the bubble for natural numbers. If I put 0 inside that bubble for natural numbers, that means, oh, 0 is a natural number, and it's not. So I'm going to put a little squiggly line underneath because I want you to realize that's something new. That's a number I cannot put in our natural number circle. But I could put some of these in my whole numbers. I could use 1, I could use 2, I could use a bunch of different ones. Give me another example of a whole number. John, go ahead and give me another example of a whole number, if you had to think of a random one. You can unmute your mic and share. Cool, 36. 36 is a whole number, right? I could count 36. It'll take me a minute to count on my fingers, but it counts, right? And I can go on and on and on. 36, 78, so on and so on. I could go on forever. Okay, let's think about integers, okay? Now, integers, the definition says all positive and negative whole numbers. So those same numbers I count on my fingers, including 0, but it could also be the negative version of these numbers, okay? So let me hear from Maxim. Maxim, go ahead and share with me. Give me an example of an integer. What's one number that you think could be classified as an integer? Okay, right? And I can say negative 30, right? We're going to get into that a little bit more, but when we read it, I would say negative 30. Sounds great, Maxim. Thanks for sharing. So that's something new, right? I couldn't put negative 30 in these circles because these circles only ask me to put positive whole numbers or positive versions of these counting numbers. Okay? Let me hear from Akshar. Akshar, give me another integer that I could use. So you can unmute your mic and share. Okay, and we're going to read that as negative 25, right? So it'd work for that too. Now, Akshar, reading my definition, it says all positive and negative whole numbers. So could I put 25 as a possible number? I could. Could I put 30 as a possible number? Awesome. I can include all of these positive versions of these numbers too. I can even include 0. I can include 1, 2, and I can go on and on forever. So notice how every time I go into another layer, if you've ever seen Shrek, you know how he says life is like an onion, it has all these layers, right? Same kind of thing, right? Rational numbers have all these layers, right? Sometimes they smell bad, but it's okay, right? So we look at these numbers to help have a better understanding of the different classifications. So let's look at rational numbers. So we talk about rational numbers being any number that can be written as a over b, where a and b are integers, and b is not equal to 0, but it's kind of like all our integers, including positive and negative fractions, decimals, and percents. Now, the other thing to think about is that some of these fractions are special cases, right? So we want to kind of consider that. So I'm going to go back up here because I didn't write my examples. So some examples I can think of just rational numbers. I could say, for example, I could say 2/3. That's a rational number. I could say negative 1/4. 97 hundredths.
You're kind of laggy, Mr. Daniel.
Okay, so when I use my document camera, sometimes it might lag, so just give it a few minutes, or give it a minute or so, and we'll catch up, okay? Okay, yeah, because even when we do like our meetings and stuff and I use my camera, same thing. And even when like another teacher uses it, kind of the same thing. 5.5, 40%, negative 12%. But it also includes all my integers. So it includes 7, it includes negative 43, 0. Okay, I can go on and on, but I'm going to stop there. Because I could go on literally forever, and I don't want to do that. All right. Question, Musa, what's up? You can unmute your mic and share.
It's like it froze and your voice for me is lagging and I couldn't even hear anything.
Okay, so this is what we can do, okay? So if you need to... All right, let's do this.
I don't understand what you're saying. It's lagging so hard.
It's going slow, okay. Let me type in this chat. Okay, check the chat, okay?
Should I?
Yes, and those are all rational numbers. I'm going to do some other examples here. Okay, Swara, what's up?
What do we have to put in the rational numbers though?
Okay, I'm gonna put some of those right now. Okay, and I'll get your question, Mustafa. Okay, so some numbers that work for rational numbers. Okay. So same thing. If you're having any lag issue, things like that, you can join. You can hang up, join back again, and this will be recorded. So I'll post it in Schoology if you need it there too. Okay. So examples of rational numbers. Okay. So I can include some fractions and decimals. So I can say 2/3. I could say negative 1/4. 0 and 97 hundredths, negative 0 and 3/10.
I can't see what you're writing, Mr. Daniel. It's kind of like paused.
Exactly.
I think you should like stop sharing and then sharing. Oh yes, now I can.
Yeah. Usually give it a minute or so because sometimes if it's lagging, especially when I share like the screen because it's like a camera, sometimes it lags a little bit from that sense. Okay? So even if you have any technical issues, remember I will post this in Schoology today. So if you miss any part of the notes in the video, it'll be there in Schoology today too. Okay? Now remember, rational numbers can also include all my integers. So I can include 0, 1, 2, 14, and I can go with a negative 5, negative 3, so on and so on. And I just put a couple extra examples in there, just so that way you can see. Okay. Musa, what's up?
So where are we in the voice is fine now?
Yeah, so here I just put some of the numbers in our box and I wrote some examples up here. Okay? So, and I'm going to explain a little bit more about rational numbers for about a few more minutes, okay? And if you missed anything, Musa, I'll upload this recording in our folder today, okay?
Wait, which folder?
If it's in Schoology, if you click on grading period 1, there's a folder before you even go into the unit that says recorded lessons, pretty much. It's the first folder. So it'll be in there. All right. No problem. Okay, so now last thing we're going to do is talk about classifying. Okay? So for example, when I put numbers in a Venn diagram, I would normally start in the middle. So if I had, like, for example, we'll do 2 examples. We'll do 3 examples. Let's do 3. And this will be the last thing we do for today. Okay? If you don't have space, I'm going to use this space over here. If you want, you can use space over here or space underneath your Venn diagram. Just don't use these 6 lines underneath because we're going to do something with that tomorrow. Okay? So just giving you a heads up on that. So let's classify these numbers. So I'll give you an example. Let's say number 1, classify. Let's say I want you to classify the number 10. Classify the number 10. Okay. So let me ask, let me hear from Noah. Okay, so Noah, unmute your mic. Noah, if I start classifying, okay, let's look at natural numbers. Can 10 be classified as a natural number? Okay, so I'm going to use the letter N. If you want to write out the word natural, you can. Okay, I'm going to use abbreviations. All right, Noah, if it's a natural number, is it also a whole number? It is. Right? Another way to think about it, notice the box for natural numbers is inside the box for whole numbers. Okay? So Noah, is it also an integer? Yep. What is it also a rational number? Yes. So I could use any one of those 4 labels to classify positive 10. Awesome. Thank you, Noah. Let's do another one. We're going to do 4 of them. Let's classify. Let's classify 0. Okay? Let me hear from Tareem. Tareem, go ahead and tell me, is 0 a natural number? You can no, it's not. I don't start counting on my finger, 0, 1, 2, 3, 4. No, we don't do that. So it's not a natural number. So I wouldn't even put 0 in this bubble. Now, Tareem, is 0 a whole number?
Yeah.
Yes. So I'd label it as a whole number. Tareem, is 0 an integer? Yes, because it's in that bubble, right? If it's a whole number, it goes in that bubble. It shares and overlaps in that same bubble. And it's also going to overlap with rational numbers as a whole. Awesome. Thank you so much. Let me hear from Kendon. Kendon, go ahead and unmute your mic. Okay? So let's go ahead and I want us to classify. We're going to do 2 more, okay? Let's classify negative 12. Okay? So Kendon, is negative 12 a natural number? No. Is negative 12 a whole number? No. Is negative 12 an integer? Yes. Is negative 12, if I put negative 12 here, would it also be a rational number? Yes. So those are the only 2 labels that I can put for a negative 12. Last one. We are going to do classify. Last one we're going to do, classify negative. 2/10. Classify negative 2/10. Now this one might be tricky, okay? But we're going to walk through it together, okay? So let me hear from Mr. Omer. Mr. Omer, go ahead and unmute your mic, team. We're going to go through each category. Omer, is negative 2/10 a natural number? No, I don't count 2/10 on my fingers to begin with, so nope, doesn't go in there. What about whole numbers? Is negative 2/10 a whole number? No, right? Because it's counting numbers in 0. I don't count 2/10 on my fingers, right? We don't do that. This is where it gets tricky, okay? Now, Omer, is negative 2/10 an integer? Now, remember, definition for an integer is all positive and negative whole numbers. So, Omer, would I count negative 2/10 as an integer? Okay? So let's think about it. Is 2/10, let's say 2/10 by itself, is that a whole number?
No.
It's not, right? And in order for it to be an go ahead.
It's a rational.
Rational, right? Because negative 2/10 is, even though there's a negative symbol next to it, read the definition, right? An integer is only a positive and negative whole number. So because of that, negative 2/10 is only rational. Okay? Now, reminder, you have an asynchronous activity due to me tomorrow. Okay? You have to do the activity I said on Monday about converting fractions to decimals and decimals to fractions. You need that for tomorrow. You don't have that tomorrow, you will be quite a few steps behind. So make sure you complete that for today. So because I still have an asynchronous activity for you, I'm going to be nice and not give you an exit ticket today. Okay? So don't worry, there's no exit ticket today. All you're required to do and take care of is take care of your asynchronous work. Now the other thing, if you lagged out or had any issues with the connection today, again, the video will be posted in Schoology. If I were you, make sure you watch it today and understand it. I have tutorials today after school at 3 o'clock if you need any help with anything else. Okay? So everybody else, if you have a question, you can stay behind. But other than that, everybody else, you are dismissed. Have a wonderful day.
Bye-bye.
Bye. Have a good day. See ya, see ya. Have a good day. Bye. Musa, what's up?
Is there any notes for the asynchronous test today?
The notes is just, there's a video in that Schoology folder, and it's like a video you have to take notes on.
Okay.
Okay, so just watch that video and take notes, and then I'll share my notes only afterwards. We want to have it before our lesson, okay?
Okay, then again, bye, bestie.
Thanks, Musa. Have a good day, buddy.
You too.
Bye, Akshar. Have a good day. Mustafa, what's up?